Hello and welcome to my new tutorial series about recreating the radar or compass system of the new God of War game. We will be using Unreal Engine 4.19.2, currently that's the latest version of the engine. However, if there are any upgrades to that during the course of the series, we will of course update to new versions. Let's launch the engine to create a new project. After having launched the engine, let's head over to the new project tab here. Everything of this project will be done 100% in blueprints, so you don't need any knowledge of C++. And if we have a look at the latest God of War game, you will see that it is a third-person action game. So the template that we will be using here will be third-person. Select that for desktop/console, maximum quality, and we don't need starter content. Then you can give it a name. I'll just call mine radar_tutorial. And then we'll hit create project. Alright, once your project was loaded up, let's go to the content root folder here. And all of the assets and classes that we create should be put in one central folder. So let's create a new folder called radar system. And because we will be working mostly inside of this folder, let's highlight that. So we can right click and set color to something like an orange. Then hit OK. Let's go in there. First off, there are a couple of icons that we want to use to display on our UI. So for that, let's create a new folder called textures or icons. I'll call mine textures. Like in all of my other tutorial series, I prepared an asset pack for you that contains all of the content that you'll need to follow along with the series. The download link to Mediafire will be in the video description. So here it reads God of War assets. Just hit the download button and you will get a .raw file. If you extract that, you get the folder with all of the assets. So let's have a quick look at them. If you've extracted the archive, these are the files that you will get. So on the very right side here, we've got the radar texture itself. That one here. Then to the very left, we've got markers for some things like main quests and side quests. The only difference between them is a color, so orange for main and blue for side quests. Then there is an icon for monsters that we also want to show on the radar. And finally, you've got icons for landmarks in the world. So these would be things like towers, bridges, or towns. And here you've got two examples of that. Please note that all of these assets are based on the actual God of War UI. However, I created all of them by myself, so feel free to use them in commercial projects if you want, or private projects. Just do with them whatever you want. Let's try to import them. So with our folder and the Unreal Engine project opened, let's go to our textures folder. Then we'll select all of the icons and move them in here. After that, we can close our folder and maximize Unreal Engine. We know that all of these icons will only ever be displayed on our user interface. And to optimize them for that purpose, we will select all of them, right click, asset actions, and bulk edit via property matrix. The property matrix is just used to change the settings of multiple elements at the same time. So here we can go to level of detail and set the texture group to UI. Then head over to compression, and the compression setting will be user interface 2D. After that, hit Ctrl and S to save all of these assets. And then there's also another thing that we want to do. For example, let's open up the landmark tower. If you zoom in, you see that this icon in particular looks very blurry when zooming in. So let's go to texture and hit that little drop down. Then under filter, you will go to nearest so that it maintains its crisp look when zooming in and out. And the other icon that we will do that for is the landmark town. The other three look good without that filter. So filter nearest, save and close that. To show the radar on the HUD or UI of the player, we need something that is called a widget. Let's go to the radar system folder, create a new folder for widgets. Then go in there and right click under user interface, create a widget blueprint, which we will call W_radar. Then open it up. First off, this is a widget that will be put inside of other widgets, which means that this setting here that currently reads fill screen should be desired on screen, so that it only occupies the size that it really needs. Then we also don't want a canvas panel in here, so just select it and hit delete on your keyboard. Instead, the first thing that we will add in here is a size box, just to make sure that our radar always has the same size. To define a size, it is as simple as checking width and height override and entering values here. These values really depend on the size of your textures or icons. For me, that will just be 696 in width and 70 pixel in height. Taking another look at the radar system of God of War, you will see that the markers for quests and the letters for the different directions, like north and south, are displayed on top of the actual radar texture. To recreate that behavior, what you need is an overlay. So if you put elements in an overlay, the widgets that are added at the end will be displayed on the ones added at the beginning. That means that the first element here will be our radar texture, but we know that we want to dynamically add widgets to this overlay, for example the quest markers, and that means that our overlay has to be a variable. Let's just call that overlay. So sometimes you just have to type in something different, then hit enter, and after that you can change the name to overlay. And as I said, the first item in that overlay will be an image, which will be the radar. So drag that in here. Let's also call that radar. Images are set to variables by default, so that's good for us. Under brush, go to image and look for radar. Okay, so that is our texture. And here you will see that the size in X of that is 696. So that was the value we entered in our size box, just if you were wondering where that is coming from. Currently our radar is located at the very top of our widgets. We want that to be in the center. So under vertical alignment, align that to the center, and horizontally it should fill out the entire space. So align fill. To be able to see just a bit of the upper part of our screen, we will lower the alpha of that, so it isn't fully opaque. Under color and opacity, I'll just lower the A to 0.7. Compile and save. So that's it already for designing your radar widget. However, in God of War, the radar isn't always visible, but only in certain situations, and we want to be able to smoothly blend it out or in, based on whether we need the radar currently or not. And for that, we will use what is called a widget animation. If you have a look at the lower part of the designer, you will see a timeline. Let's drag that up so we can see it. And on the very left side, you've got animations. Let's add one called blend out. If you then double click it, your timeline is now selected, and you get that red button here, which will define your time. To make an animation, you need what is called keyframes. So keyframe is basically a point of time in your animation where certain values are set. So for example, at the very beginning of our timeline, we want our radar to have the alpha of 0.7. If we want to do that, just hit that little keyframe button here, which adds a keyframe for this property to the current animation, and you will see that appearing here. Now the timeline knows that we want to animate the color and opacity, because we added a keyframe for that. Let's say our animation should take half a second to complete. So move your timestamp to 0.5. And to blend it out, the alpha has to be 0 by that. So just type in 0, and before hitting enter, hit that little add keyframe button again. Alright, knowing that 2 keyframes, your animation will be able to fill out the other frames so that it smoothly transitions from an alpha of 0.7 to 0. We don't need an extra animation for blending it in again, because if we have a look at that, if we play that animation the reverse way, that is exactly blending it in. Alright, so you can use one animation for the 2 cases. Sometimes when working with animations, it messes up some of the values of your widget. To fix that, just compile, save and close your widget and then open it up again. Yeah, now you see that no animation is selected. However, our radar isn't visible, so select it and we'll set the default of alpha to 0.7 again. Okay, then compile, and that's it for our radar. The radar is just an element of the player UI, so we have to put it inside another widget that is then added to the player screen. Let's add a new widget blueprint, and mostly you call this the main widget because all the other sub widgets are put inside of it. Let's just call it w_main and open it up. We don't need the animations anymore. And taking a look at the UI of God of War, you'll see that the radar is placed at the upper side of the screen and vertically aligned to the center. So if we want to mirror that behavior, go to the user created category. There you find your w_radar, drag that in. Let's just call that the radar widget and make sure it's a variable so we can access it later. Then hit size to content. So that will make sure that the actual size of that widget here is used, which is defined in its size box. If that is not selected, we could just mess around with the size in X here, and that would look really strange. So just hit size to content, place at the upper center, so under anchors, select the upper center. Then in alignment, give it an alignment of 0.5 in X, And if you then set the position in X to 0, it will be aligned to the very center vertically. Position in Y could be something like 20, so an offset of 20 pixels to the very top. And just in case you ever add elements to your main widget that could be overlapping the radar widget, we still want that to be on top. So just give it a very high Z order, for example of 10. Okay, compile and save. Now we've created our main widget. However, we still need to tell our player that he has to add this widget to the viewport. Otherwise, we won't see it at all. Let's close the main widget back in our radar systems folder. And we want to put everything related to the behavior of the radar in something that is called a blueprint component. If you've watched my Fortnite tutorials series, you already know about the advantages of blueprint components. For all of the other people, I'll just quickly explain that. A blueprint component basically is just a class that handles certain behavior and which can later be simply added to other classes that then use this behavior. For example, your third-person character has one component that handles the movement, that is the character movement component. And if we create a radar component, we could simply add that to the third-person character, and that way the player owns a radar that is then displayed on the screen. Also, it would be very simple to migrate our radar component to other projects. For example, in the last episode of this series, I'll show you how you can quickly migrate all of the assets to a first-person shooter game. And that is much simpler if all of the logic is contained within an actor component and not, for example, a third-person character. So hopefully you've understood the advantages of a blueprint component. Let's add a folder for components and open that up. Then right click and add a blueprint class. Then select the actor component as your parent class or base class, and we'll call that BPC for blueprint component underscore radar component and open it up. In here we don't need the event begin play nor the event tick. Instead we want to add one custom event and call that initialize radar. That event is called when our radar should start functioning. And first off, what we'll do here is we will create a widget. Class for that will be main widget. And we have to access especially the radar later. So let's grab the return value, promote to a variable called main widget reference. Then off of the main widget reference, get the radar widget. So we will deal with that widget a lot, and that's why it's smart to make that a variable in here too, because otherwise we would always have to first get the main widget ref and then the radar widget. So we can leave out one step by promoting that to a variable called radar widget reference and setting that after the first reference. After that, let's grab our main widget reference and let's add that to the viewport. All right, compile and save that component. We have to tell our player that he owns a radar, so close your component and open up the third-person character. Open Blueprint Editor. First off, let's remove the events for VR here and touch input, don't need that. Also don't need gamepad. Then there will be the Components tab in here, and just simply add a component and look for BPC radar component. You can give that a name, for example, player radar. And now we have to call that initialize event we just created. In the event graph, let's look for event begin play. Then simply drag in the player radar and call initialize. Another thing we want to do, just so that our project feels more like the actual God of War, is to adjust the camera position. We have a look at God of War, that is a third-person action game, and the camera is positioned very close to Kratos and a little bit above his right shoulder. Let's try to mirror that behavior a bit. Go to viewport, then select your camera boom. So that is basically responsible for the position of your follow camera. And to move the camera closer to your player, set your target arm length to something below 300. Let's take the half, maybe 150. Then go to your socket offset, and in Y we will increase that to 20. So that is somewhere close to the right shoulder. If we then move it up in Z by 80, that looks somewhat right. Now we also have to rotate our camera so that it looks downwards a bit. Select your follow camera, and the rotation in Y will simply be -10. Alright, compile, save. If we then play in a new editor window, you see that the camera is somewhat similar to God of War, and our radar is actually displayed here. However, we didn't add any functionality to show and hide it based on the situation, so let's do that. Can minimize our third-person character, we will return to it later, and open up our radar component. In here we need two variables of the type boolean. The first one is called visible ? So are we actually showing the radar right now? And the second one will be can change visibility. Basically what this boolean here means is the player able to select a different visibility? For example, he would not be able to do so when we're currently playing the animation to hide or show it. Compile and save, and we will set the default values to true. So by default our radar is visible, and by default we can change the visibility. Then we will add one custom event that we will call setVisibility. So this will handle showing or hiding the radar, and that needs two inputs of type boolean. First one called visible. So do we want to show it? If so, that would be true. If not, it would be false. And second one will be animate ? So do we instantly want to hide it or slowly blend it out? For example, if you enter a cutscene and fade to black, you could simply just set the visibility to hidden without animating it. Before we continue with any logic, we need a branch, so a check if we're actually able to perform the action. And we want to see whether the visible input is not equal to our visible variable. So that simply means if we're already visible, we don't want to show it, or if it's hidden, we don't want to hide it. And there will be a second condition, so look for an AND connection. That will be can change visibility. So are we able to change the visibility, and do we want to set the visibility to something else than its current value? These are the two conditions that have to be met in order to proceed. So if both of these conditions are met, we will first set can change visibility to false, then set visible to the input visible. So we update our two boolean variables, and after that we will need another branch. Because we need different functionality based on whether we want to animate it or not. Connect your input animate to the condition. And let's do the false path first, so that's simpler. Grab your radar widget reference and set visibility. Hook that up to false. For the invisibility, look for a select node. Drag in your visible boolean as the index. And now you can select a visibility based on your boolean. If our boolean is true, means we have to show it, and then we'll set it to self-hit test invisible. That means it is shown, but your cursor won't hit it, and false will be hidden. After that, we will set can change visibility back to true, so that we are able to call this event again and pass the first branch here. Alright, that's it for the false path. That's very simple. For the true path, we have to add another branch. So the third one here, and plug in the visible boolean. If that is true, means we have to show our radar widget, drag in the radar widget reference and set visibility to self-hit test. After that, off of it, play animation. Now we want to slowly blend it in, and the animation for that is blend out. Hook that up as the in animation. As I said, the play mode will be reverse. So playing blend out reverse will blend it in. And while that animation is playing, our can change visibility has to be false, and after that will be reset to true. To do something at the end of an animation, what you do is get the end time of your animation. So that's the duration of it. Then look for a delay node. And after that's completed, we will set can change visibility to true. If it's false, that means we have to hide our radar widget. So in that case, let's copy over our play animation, hook up the radar widget, and let's get the blend out animation once again. Hook that up to the in animation, but this time the play mode will be forward. After that, we also have to wait until the end of the animation, so add a delay node, and again get the end time of your blend out animation. Hook that up to the duration. Once that is completed, we can copy over our radar and set visibility to hidden. Then also set can change visibility back to true. Let's quickly recap what we are doing in this event. So when we call it, we first have to check whether that action we want to perform is valid. So are we able to change the visibility, and do we want to set it to something else than its current value? If so, we will temporarily disable changing the visibility. You can't call that event twice right after you've called it before, and then set a visible boolean to the input. After that, execute different functionality based on whether we want to animate it or not. If not, it is as simple as setting the visibility of the radar widget, and after that re-enabling change visibility. If you want to animate it, we will check whether we want to show it. That would be the true path, or hide it. If we show it, we first have to make our radar widget visible, then play the animation to slowly increase its opacity. And once that is finished, we will set can change visibility to true. So after that animation is played, you will be able to call that event again. If we want to hide it, we first have to play our animation to blend it out, and after that is completed, set the visibility to hidden. Like in the upper part, then we will set change visibility to true, so that after the animation you're able to call this event. Let's also add the functionality to toggle visibility. So if it's currently visible, then make it hidden, and if it's hidden, show it. Add a function for that called toggle visibility. That will need one input of type boolean called animate question mark, and we will simply call set visibility. The animate comes from our input, and like I said, we want to set the visibility to the opposite of its current value. To do that, just grab your variable visible and add a not boolean. So that's the opposite. Connect that to visible, and after that return. Compile and save. So that's very simple logic here. The only thing left to do is to assign that functionality to an event that the player can trigger. For example, by pressing a key on your keyboard. Let's go to the third person character, to the event graph, and let's say we will use the C key for that. So right click somewhere and enter C key, and there you find it. Once that is pressed, just drag a pin off of your player radar and call toggle visibility. Let's leave the animate as false right now and compile and save. If we play, currently seeing the radar widget. If I hit C, it will be hidden. Hitting C again, it will be shown. Currently, that's not a very smooth transition, so that's very simple to fix. Just check your animate boolean, and then if I hit C, it will slowly blend out, and I can hit C again, so it slowly fades in again. Alright, that's the end of this first episode. In the next one, we will handle showing the different directions, like north and south on our radar, and updating their position on the radar based on where the player is looking. So see you then.